A very good day to Dr. Umni. Today, our group will present about the group project for data structure and algorithm. So this is our group member, Chia Jerong, Lei Wei Jun, Chao Zhongxian, Sun Rongjun, Lucas Lau, and Jason Yap. The application of the chosen algorithm in solving a real-world problem that we choose is student grade, which include function on searching of student details by metric ID and sorting of students by course marks. In this C++ program, we are using sorting algorithm, which is bubble sort, and searching algorithm, which is sequential search, and we also use linked list. Now, we will demonstrate about the C++ program.
Okay, now I would like to demonstrate the our output is wet. I need to share the screen. Okay, first, we need to add the new student. Then we store the first data and another one. And another one is we can display the student record which we previously add. It's like this. And after that, we can search the student based on the metric number. So we can find Uni is in the data. The data is in the list. After that, we can sort the student by mark. So we can see sort ascending order. So we finish our program. So now I would like to explain our code. Let me show our slide. This is our full code for the sequential search. So we will explain line by line. So the first is a string variable target is declared to store the metric number to search for. A pointer pcurrent of type nodes is initialized to point to the head of the list. The user is prompted to enter a metric number which is then read into the target variable. And the diagram is showing the second line of the code.
Okay, for this sequential search, we did use if-else statement as our method check. We use this method to check whether the count of the nodes in the list is 0 or not. So if there's no nodes in the list, which is the count equal to 0, it will print out nothing to search and exit the method. So else, if the nodes in the list is not equal to 0, which is there's some nodes in the list, and the method will enter into the while loop to search the target matriculation number. And then the loop will continue to iterate as long as the metric field of the current nodes, which is the p current, is not equal to 0 to the target, and the link field of the current node is not null. So within the loop, the p current will keep updating to the point to the next node in the list. So this is how we can visualize the searching process throughout the process to search for the target.
After the loop, the method checks if the current node's matrix field is equal to target or not. If pcurrent point to the matrix is equal to the target, it means the target matrix number was found in the list. The method then prints out the data is in the list, the name, the matrix number, the mask fields of the current node, which is the pcurrent. If pcurrent point to the matrix is not equal to the target, it means the target matrix number was not found in the list. And then the method will print out the data is not in the list. This is the visualize of the searching. The P current is pointed to the next, to the next, to the next. It will loop until the target matrix number is found. Then it will print out the data is in the list, the matrix number, mask, field, and current node.
The next part is for barbershop, and then this slide shows that the full code of barbershop. Then I will explain what the meaning of the first query line of barbershop. For swap, an individual use a keep track of whether any swap when made during an iteration of the list. Then the second line, PTR1, show that a pointer of time loop used to traverse the list. The third line, that LPTR is meaning that a pointer of time loop used to mark the end of the shorted portion of the list. The next page shows that the example how PTR1 and LPTR to traverse the data.
Next is the explanation of sorting algorithm bubble sort. The method checks if the head of the list is null, which is indicating an empty list. If the list is empty, the method will return immediately as there is nothing to sort. The outer do while loop continues as long as swap is non-zero, indicating that a swap was made in previous pass. Swap is set to 0 at the beginning of each pass. PTR1 is initializing to point to the head of the list at the start of each pass. The inner while loop traverses the list from head to the last unsorted node, which is LPTR. If the marks of the current nodes PTR1 are greater than the marks of the next node PTR1 to link, the swap function is called to swap the data between these two nodes. Swap is set to 1 to indicate that a swap was made. PTR1 is updated to point to the next node, which is PTR1 to link. After each pass, a PTR is updated to the last node that was compared, which is now the end of the sorted portion of the list. These are the example of the sorting algorithm bubble sort. The swap is equivalent to 0 and the PTR1 is in 34 and the LPTR is in 83. Next, swap equivalent to 0 and the PTR1 is in the 45 and LPTR is in 83. This is because the bubble sort arrangement is more too big than the PTR1. The 34 is arrangement is correct, so no need to change everything, just turn into 45. Next is 48 in PTR1 and 83 is on the LPTR, while swap equivalent to 0. Next is 56 in PTR1 and 83 in LPTR, while swap equivalent to 0. So in this part, while swap is equivalent to 0, 56 is in PTR1 and 83 is LPTR, the number of 56 is bigger than 51, so the 56 will sorted with 51 and turns into swap was equivalent to 1, then the PTR1 will located on the 56 and the 83 will on the LPTR. So thank you.
Okay. Okay. Bye bye. Thank you.
Thank you, madam.
Thank you,
Bye.
madam.
Thank you, madam.